Can everybody draw a normal curve as a mean of 12? Do so. Draw a normal curve with a mean of 12.
Paper. That's paper.
So many things. Sebastian, could you turn off a couple lights, man? Thank you. Alright, so today's lecture brought to you by Sony. Oh, there you go. This is very helpful. That is a super zoomed in normal curve. Do it. All right, so here's normal curve, mean to 12, yes? When is the middle 0? When's a really good time that the middle might be 0?
Are you talking about z-scores?
Yes, z-scores, or the mean could just be 0, right? But yeah, so in the middle's got to be the mean. And let's say, so the mean is 12, and let's say the standard deviation is 1.92. Just to get some beautiful decimals in there. And I know it's normal. That's the first thing I said, this sucker is normal. All right. So I want to know, if I pick one thing from this population, what's the probability that that thing is greater than 14? Oh, someday I won't be stuck. All right, so even if you've missed some class, do you see, can you find 14 in the picture? Can you shade in the part of the picture that that's asking for, right?
Yes.
Okay. And then maybe some of you guys would be like, yes, I could do that. No idea what the shit to do after that. If it was a uniform curve, we would shade it in and then just find the area of the rectangle that we just shaded, right? That would be awesome. This is not a geometric shape that we talk about, right? This is an anthill. This is I don't know, an old wig. I don't know what this is. So here's 14. I want the probability that it's more than 14. Okay. So the whole idea is, if I know it's normal, we have the empirical rule first. Within 1 is 68%, within 2, blah, blah, blah. Come to find out, that's just 3 numbers from everything. If it's normally distributed, we know everything about it. We know how much area there is here, there, wherever. We just need somebody to help us just to tell us. Because again, that shape, I can't do the area of that damn shape. But if somebody would just tell me what the area is, we could do stuff. So we have this chart. Does anyone not have this chart yet? We just got that? Okay. So what do I need though before I can use this? I need to know it's normal. Check. What else do I need? Guys are all like,
It's continuous. Wait, you need the z-score.
easy space. Okay. And it's continuous. All right. So how do I convert this into a z-score? We already said this would become 0, right? So I like to put my little z-scores, little parentheses underneath the number, keep myself straight. How do you convert 14 into a z-score? What's the formula for z-scores?
X minus the mean over, or divided by standard deviation.
I like it. And again, it's, the whole idea of z-score is how many standard deviations fit between the mean and the data point, right? How many standard deviations fit between the mean and the data point? I mean, that's what division really means, is how many of these things fit in the middle of these things. Well, at least it's one way to interpret it. So now I just gotta throw stuff in, right? 14 is the data point I'm curious about, the mean is 12, and the standard deviation is 1.92. Before I even do this, though, I know it's gonna be positive or negative.
Positive.
Positive because it's
On the right.
above the mean, yeah. So I have no idea what you get. 0.0800. Screw it, I can't.
You get 1.0416.
0.0416. So where would I stop? Considering what my chart could do.
1.04.
Yeah, so always round it to that place. Don't just cut it. Why is that a 4? Because the next number's a 1, if I remember what you said.
So it would only be 2 decimal places over that you.
Yes, why? Why do we do these 2, Jeff? What's wrong with you? Because what's the chart do? It only goes out
Oh,
to
got
2
it,
places.
okay.
Yeah. See, that's the one that definitely makes the most visible. Our chart only goes out 2 places. So of course we're going to convert that to 2 decimal places. All right. So if I look up 1.04, am I going to get the actual answer? No, we're not. Let's do it anyway, because we're all crazy. 1.04. Okay, 8508. That's not the answer, but why is it still useful? Because where does it go in the picture? 8508, where does it go?
On the other side.
Yeah, whenever I look up a z-score, so my z-score is 1.04, it's the area that's below what I just looked at. And of course I took too long. 8508?
Yep. Yeah.
So then what's this? What's the answer gonna be?
1 minus.
Yeah, 1 minus that. 0.1492. Aw, you gotta love this. Killer of civilizations. Okay. Maybe. Okay, so let's find out how you really feel.
So if
Yes.
the standard, or I'm sorry, if you get the z-score and, or let's say the number was like 10 or 9 or something.
Oh, like instead of 14, it was 9.
Yeah. So
And the
since
z-score would have been,
So if it's on the left side, you don't have to, once you find the z-score, that's.
it'll be negative.
Okay, yeah.
Yeah. And but we would have done the exact same work. If it would have said, all right, let's do it real quick. What if instead the question was, what's the probability x is greater than 9? Right? Instead of 14, what if it was 9? So let's see, the picture would basically start the same, but there's my name's done. My name's down there. You betcha. Okay. Just to remind you guys, the mean was 12, standard deviation 1.92. All right, it's the same work. I just got a slightly different number. I still make a z-score out of this dude. It's like 1.52, maybe? Negative 1.52. I don't know.
Negative 1.5625.
Damn it.
You're close enough.
No.
Okay.
You're nicer to me than I am. So negative 1.56. And again, what's going to happen? If I look that up, I've got to look on the negative side of things. On the negative side of the street. Negative 1.56. Right? 0.0594. Where is that on the picture?
On the left side.
Yeah, it's this area. And then again, 1 minus. So do you see how the work was exactly the same? Just the numbers changed. So that'd be 0.9406. Holy shit, Jeff. Don't write when you're looking at the screen, Jeff. Oh, don't write, just don't write. Okay, it's probably generally a good idea for me. Yes?
This is, since I missed, Tuesday, is this, 6.2?
Yeah, this is chapter 6.
Or chapter 6?
Yeah, yeah. I mean, 6.1 I think is z-scores. 6.2 is where they bring in x stuff.
Okay.
Yeah. Okay. All right, so let's find out. Yes. Okay, so let's do this real quick. Show you something. Let's just look at a standard normal curve. And all that means is I've got z-scores. So it looks like this. So let's say, what's the probability that a z-score in a standard normal curve is less than negative 1.03, right? So there's two levels to this. There's the level of, can you just draw the picture and shade in the area I want, right? There's that level of it. And some people are just kind of not going to do this, and those are the people that are going to make the most silly mistakes. And then there's a level of, all right, you got a picture. What the hell? Well, if I look up, so here's how this works. I want to look at the negative side, right? A negative z-score. This tells me the first decimal place. Negative 1.0, negative 1.03. So what area is below negative 1.03 z-score? 15.15%. So, yes, it tells you the area below that, right? And this chart could have been done in a lot of different ways, and I've seen it done in a lot of different ways. And they would all show essentially the same thing. This chart says, all right, if you start at negative 3.49, I think, or 350, it's almost 0% below it, which makes sense. Negative 3.5 is way the hell down there. How much is going to be past that? Basically nothing. As you move up, you're collecting more below it. Right? Until, of course, you get to 0, in which case you have how much below? 0 cuts it in. 0 cuts it in half. So, you start at negative 3.5, there's basically nothing below it. Right, that's down here. As you move up, aren't you collecting more and more area below you? Why is it not growing very much at first? Because look how skinny this is. It's not adding much. But the minute I start to get into the meat of it, it starts to increase more and more until I get to 0.5. Where you want there? There you are. 50% at 0.00, right? That's 50% there. So that's all this chart does. And the specific numbers, why is that 0.0207 right there? Why is it 0.0207? I don't know. Because that's the area. We're using that funky ass formula that I showed you that one time. Do you guys remember that formula I showed you? Maybe some of you guys? Okay, so there's a reason it's specifically that, but how much can we at least understand? I see why it grows as I scan down this, because I'm getting closer to the middle and I'm getting more below me. So the way this thing is set up is when I look up a z-score, I get the area below it. That's why if my question doesn't say probability less than something, I got to do something. If it's between two, I got to subtract two things. If it's above, I got to do one minus the thing. I got to adjust what the chart tells me But I like that better. I'd rather have one piece of paper chart instead of a little binder of charts to look through. All right, let me see, it's this situation. No, I'd rather just look several things up and do it. Okay, is that better? Okay, so. Where have I put this? There it is. Oh, Jeff. When you get older, you can play tricks on yourself. So, don't look at the side with blue and yellow on it, okay? Don't look at that yet. Up here. Oh, let's see it. Go behind you. No, behind you. And now go over there. Okay. Does everybody see the problem? It's a little district in New Zealand. Oh, what happened? I thought there was enough. No? Oh, no. Oh, you didn't get one. I just can't count, that's all. I don't know if that's a big deal. So this side, right? I think I created this worksheet maybe 4 years ago, 3 years ago. So all this was true then. Maybe it was more recent, I can't remember. Yeah. So go ahead and try that out. Do those problems. Let me know if you need some help.